Okay, here we are in section 8-3, and what we're working on today is graphing general rational functions. And when we graph general rational functions, we have any number of things that they're going to throw at us, but basically they're in fraction form. So you're going to have a lot of times where you're going to have things like f of x, and then you're going to have a big old polynomial on the top and a big old polynomial on the bottom. And you got to figure out what's happening there. So when we have the x-intercepts of the graph of f are all the real zeros of p of x, so all the things that would make the top 0, and then all the vertical asymptotes would be all the things that would make the bottom 0. So because you can't have 0 on the bottom, that creates a vertical asymptote. And on the top, if you had 0, obviously that would make a 0 because you'd have 0 over something. As far as the horizontal asymptotes go, there's a couple of things. If you look at your m and your n, those are important things. Your degrees of each polynomial, the top one and the bottom one. If m is less than n, then your horizontal asymptote is going to be y equals 0. Now you're going to have at most one horizontal asymptote. At most one horizontal asymptote. If m equaled n, then you would take those two leading coefficients, and in this case they would be a sub m and b sub m, and then y equals a sub m and b sub n over top of each other. Those would be your horizontal asymptote. And then if m was greater than n, and a couple of the functions we're going to do have those as well. If m is greater than n, then you're going to have no horizontal asymptote. Alright. The end behavior is the same as y equals, and when we talk about end behavior, we're talking about what happens out over this way and down over this way. The end behavior is the same as what happens if I had exactly this function right here. Now that really helps us do things by hand. Most of us will probably do things on our calculator, so we won't worry too much about doing it by hand, but we will do it. We'll graph a couple of them by hand just so we know what it looks like. When we graph y equals 3 over x squared plus 2, some things that I know right away. I know that the m on the top, that variable of my exponent on the top, well, there is no exponent on the top, so that m is 0. So my m is less than 2, which is my exponent on the bottom. So when they were less than, we had a horizontal we had a horizontal asymptote right here at y equals 0. So I know that's going to be my asymptote. The numerator has no zeros, so there is no x-intercept. So it's never going to come inside and touch my asymptote line, obviously, so there's no zeros. The denominator has no real zeros, and so if there's no real zeros on the denominator, you don't have a vertical asymptote at all. Alright. The degree of the numerator in this situation is 0, and we've already kind of talked about that, is less than the degree of the denominator, which is 2. Say 0 on the top, 2 here on the bottom. So the line y equals 0, which we've already drawn, is going to be our horizontal asymptote. The domain is all real numbers, and my shorthand, remember, for all real numbers is kind of like that paragraph symbol. And the range of this thing, you see how y will never get down to 0 at all. And the highest point, or that max point that it's going to get to, if this thing's going to approach down here, it's going to approach down here, the highest point that this thing's ever going to get to is when right in the middle where x equals 0, which happens to be 3 over 2, and you're going to see that a lot. So y is going to be between 1.5, which is 3 over 2, and 0. It's going to be between those 2 points. So at most, it's going to be right here at 1.5. So it's going to do this, up, and back down. And if you graph that on your calculator, you'll find that to be the same thing. Go ahead and do the checkpoint. And, you know, if you want, just throw it on your calculator and see if you can make some, you know what the domain and the range is. Give yourself about 30 seconds to do that. All right, welcome back. Hopefully what you found was that the domain was all real numbers for all the same reasons that it was in our example 1. And the range, well, y had to be greater than or equal to 0 because it had that asymptote as well. Not or equal to, just greater than. And but it had to be less than or equal to 3 because of that 12 divided by 4 was 3. So 1, 2, 3, we had a point right there at 3, and so we look something like that. Hopefully you guys got that. All right, let's take a look at example 2 here. In example 2, it looks like this is one of those instances where m equals n, and we talked about that earlier when we said m equals n. You're going to have those leading coefficients. In this case right here, we have a little 1 and a 1 that are out there. So the zeros of this numerator, x squared minus 9, well, what numbers could I put in for x to make the top 0? And hopefully when you read that, you're saying, oh, I know, they're plus and minus 3. 3 squared is 9, and negative 3 squared is 9, so 9 minus 9 is going to be 0. So negative 3 and 3 are those x-intercepts. So 1, 2, 3, I got a dot right there. 1, 2, 3, I got a dot right there. All right. Denominator, x squared minus 4. Those are plus and minus 2, 2 squared, and negative 2 squared. So I have 2 and negative 2. Those are going to be my vertical asymptotes. So I'm going to go right to 2, and I chose red as my asymptote color. All right. So I'm going to have these 2 crazy-looking vertical asymptotes right there. All right. And y, the numerator and denominator have the same degree. So the horizontal asymptote is my leading coefficient on the top, which is 1, and my leading coefficient on the bottom, which is 1. So 1 divided by 1 is 1. Remember those leading coefficients I pointed out to you were right there. And so I have this line, this other asymptote line that goes across right there. So it's kind of going to look a little crazy. When I plot, and kind of I can just plot some points, but one thing you're going to note is, remember that those 2 last numbers, those negative 9 divided by negative 4, is 2.25. Well, that's where x is 0. So if you look at 2.25 is right around there somewhere. Here's what's going to happen. Because I know some of these points, and probably most of us have already tried to graph this on our calculator, you're going to end up with something that looks like this and something that looks like this. Okay? Throw that on a calculator, and that's what you'll find. Make sure if you put it on your calculator, though, you do x squared minus 9, and you put parentheses around it, divided by x squared minus 4, and you put parentheses around that. The parentheses in that situation become vitally important. Final page here. This one, as you can assume, it's going to just look a little bit, every time it gets a little harder and a little harder, right? Y equals x squared minus 2x minus 3 over x squared plus 2. That's a situation where that m is greater than n. The numerator factors, and so if we take the factors of the numerator, I hope you all see that that's x minus 3 and x plus 1. And that's reverse foiling or factoring, right? So, numbers use the snip method or whatever you use to get that. But when negative 3 and 1 multiplied to be negative 3, they added to be negative 2, so that's how I factored that out. So the x-intercepts, the things that would make the top 0, would be 3 and negative 1. The 0 of the numerator, x plus 2, is negative 2, all important numbers. So the vertical asymptote is at negative 2. X equals negative 2. That means I have my x equals negative 2. I have a vertical asymptote right there. And I have some points at 3 and negative 1. Looks like that right there. 3 and negative 1 give me a couple of zeros. And things that happen when you approach an asymptote, when you come in and out of asymptote, it's very sharp. It can't cross it, and it rarely goes to an asymptote, makes a hole, and goes. It generally makes a swoop in and out of that asymptote. So we'll see if ours does the same thing. The degree of the numerator is 2, and that's greater than the degree of the denominator, 1. So the graph has no horizontal asymptote. Refer back to the a couple pages ago when we talked about that. So the graph has no horizontal asymptote. The graph has the same end behavior as, and this is where that thing came in earlier, as y equals x to the 2 minus 1. The same end behavior as y equals x. And when we talk about end behavior, we're talking about up here, y equals x would make a line that would do this and would do this. And so what happens with that, because the end behavior is a y equals x, that line, and let's signify what that line would look like in green here. Y equals x line would look like this. It would go all the way through your page like that. And so when I'm talking about my graph, it's not going to do that around the asymptote because it's got to turn, but it's certainly going to do that when it's not around the asymptote. When I look at that being my end behavior, I think, okay, it must come down, crosses, and then it swoops back up along that asymptote, and it makes a little U. All right, and guess what this little point is? Right here in yellow. This little point right there in yellow is at negative 3 over 2, or negative 1.5. It comes down, it touches that, and it goes back up because all the x's were 0 right there. So that's good to know. All right, and then the points down on the other side are really the ones that become a little bit more important to me trying to figure out where they are and what they're doing. The points down on the other side, maybe some of you have already graphed this and you kind of already know, but if I threw a negative 7 in here, and I did all the math to it, negative 7 would result in negative 12. And if I put a negative 6 in there, negative 11.3. If I put a negative 4 in there, negative 10.5. See, those numbers are starting to get a little bit smaller. And then I put a negative 3 in there, it goes back to negative 12. So what happens is this thing comes back up here, and then it swoops, and then it goes back down. And if you graph that on the calculator, that's what you're going to find to be true. You guys take 30 seconds or a minute or 2 or however long it takes you to do checkpoint 2 and 3 there. Okay, welcome back. Now on this one, we have, we're going to have an asymptote. What's going to make, what are my asymptotes going to be? Well, what's going to make the bottom 0? The bottom's going to be 0 at 4 and negative 4. So I'm going to have an asymptote right here and right here. Okay, so it's going to be one of those graphs that has 3 components to it. Where's going to be my horizontal asymptote? Where am I going to have one? Well, because the degrees are the same, then it ends up being the leading coefficient 3 divided by 1. So I have right here, and then I'm going to throw some points down. I'm going to graph a few points and see where I end up. If I were to put zeros in for those x's, I end up at 0, 0. So I know my graph's going to end up down here somewhere. And if I throw it in my calculator, it's going to end up looking something like this. Hopefully you got that. Things you'll have to know. I mean, obviously, if I ask you to graph that on a test, you're going to have to graph it. But things you'll have to know for the test is where are those asymptotes and some of the key points that are in there. Could you find those key points? That's what's going to be important. All right, let's take a look at number 3 here. Now, number 3 is just like this last one we did, where the top degree is larger than the bottom degree. And if the top degree is larger than the bottom degree, then that's the one where you don't have that horizontal asymptote, right? But you have those end behaviors, and those end behaviors become the same as y equals x squared over x, or y equals just x. So that means that it's going to be here, and it's going to be here eventually. I also know that I have a vertical asymptote at 1 right here. So when I graph that thing, it's going to come down, and it's going that way, it's going to go up, and it's going to go that way. All right, hopefully that's what you got on your calculator. Good luck with that, and we will see you tomorrow.